In a world grappling with environmental challenges, understanding our impact on the planet is paramount. Life cycle assessment, or LCA, emerges as a vital tool in this endeavor. It's a comprehensive approach to evaluating the environmental performance of products, processes, or services throughout their entire life cycle. Imagine tracking a product's journey from its raw material extraction to its eventual disposal. This is the essence of LCA, providing a holistic view of its environmental footprint. LCA is not merely an assessment, it's a pathway to informed decision-making. By quantifying environmental impacts, LCA guides us towards sustainable choices. It empowers industries to minimize their ecological footprint, policymakers to craft effective regulations, and consumers to make eco-conscious decisions. LCA is more than an environmental audit, it's a roadmap to a sustainable future. Imagine LCA as a journey with 4 distinct stages, each crucial in painting a complete environmental picture. The first stage, goal and scope, defines the assessment's purpose and boundaries. What are we assessing and why? What are the specific environmental concerns? Next, inventory analysis meticulously accounts for all resources consumed and emissions generated throughout the life cycle. This stage involves data collection and analysis, tracing every input and output. The third stage, impact assessment, translates this inventory data into environmental impacts. It categorizes and quantifies the effects on human health, ecosystems, and resource depletion. Finally, interpretation draws meaningful conclusions from the assessment, identifying areas for improvement and informing decision-making. This holistic approach ensures a thorough understanding of the environmental implications. The versatility of LCA is evident in its application across diverse industries. Let's delve into a few examples. In the food industry, LCA helps assess the environmental impact of different agricultural practices, packaging choices, and transportation methods. The construction industry utilizes LCA to compare building materials, optimize construction processes, and design eco-friendly structures. Manufacturing industries employ LCA to evaluate the environmental performance of products from electronics to automobiles. Even in renewable energy, LCA helps assess the environmental trade-offs associated with different energy sources, such as solar, wind, and hydropower. LCA's adaptability makes it an invaluable tool for various sectors striving for sustainability. The insights gained from LCA are invaluable in guiding sustainable choices. For businesses, LCA facilitates informed decision-making, enabling them to identify environmental hotspots in their operations. By pinpointing areas for improvement, companies can reduce their environmental footprint, enhance their brand image, and gain a competitive edge. LCA also aids in product development. By assessing the environmental performance of different design options, companies can create eco-friendly products that meet consumer demand for sustainability. Moreover, LCA fosters transparency and accountability, allowing companies to communicate their environmental performance to stakeholders and build trust with consumers. Section 5. Quantifying impacts, measuring our environmental legacy. One of LCA's key strengths lies in its ability to quantify environmental impacts. These quantifications provide tangible metrics to assess and compare different options. Carbon footprint, a widely recognized indicator, measures the total greenhouse gas emissions associated with a product or process. Water footprint quantifies the amount of water used, considering both direct and indirect water consumption. LCA also assesses resource depletion, air and water pollution, and potential impacts on biodiversity. By translating environmental impacts into measurable units, LCA provides a clear understanding of the consequences of our actions. This quantitative approach is crucial for setting targets, tracking progress, and making informed decisions. Section 6. LCA in Product Design, Engineering a Greener Future. Imagine a world where products are designed with their entire life cycle in mind. LCA plays a pivotal role in making this vision a reality. By integrating LCA into the design process, engineers and manufacturers can create products that minimize their environmental footprint. LCA helps identify materials with lower environmental impacts, optimize manufacturing processes to reduce waste and emissions, and design products for easier disassembly and recycling. This approach, known as eco-design or sustainable design, is gaining traction as businesses recognize the environmental and economic benefits of resource efficiency and waste reduction. Section 7. The challenges of LCA: navigating data and regional differences. While LCA offers a powerful framework, it's not without its challenges. Data availability and quality are crucial for accurate assessments. Gathering comprehensive and reliable data throughout the entire life cycle can be complex and time-consuming. Regional variations in environmental conditions, energy sources, and waste management practices can also influence LCA results. Moreover, LCA is a dynamic field with evolving methodologies and impact assessment models. Addressing these challenges requires robust data collection protocols, regional adaptation of assessment methods, and ongoing research to improve LCA methodologies and address emerging environmental issues. Section 8. LCA and policy making: shaping a sustainable tomorrow. LCA extends beyond corporate sustainability, playing a crucial role in shaping environmental policies. Governments and regulatory bodies utilize LCA to inform regulations, standards, and labeling programs. By understanding the environmental impacts of different products, processes, or policies, policymakers can make informed decisions that promote sustainable consumption and production patterns. LCA supports the development of eco-labels, such as carbon footprint labels, which empower consumers to make informed choices. Furthermore, LCA can be used to assess the effectiveness of existing policies and identify areas for improvement, guiding governments toward a more sustainable future. Section 9. The future of LCA: technological advancements and emerging trends. The field of LCA is constantly evolving, driven by technological advancements and emerging environmental concerns. Software tools and databases are becoming increasingly sophisticated, streamlining data collection and analysis. The integration of big data and artificial intelligence holds immense potential for enhancing LCA's capabilities. Researchers are exploring new impact categories, such as biodiversity loss and ecosystem services, to provide a more comprehensive assessment of environmental sustainability. Moreover, there's growing interest in social LCA, which expands the scope to include social and ethical considerations throughout the life cycle. Section 10. Conclusion: embracing LCA for a sustainable future. In conclusion, life cycle assessment is an indispensable tool for navigating the complexities of environmental sustainability. By providing a holistic understanding of a product's environmental footprint, LCA empowers businesses, policymakers, and consumers to make informed decisions that reduce our impact on the planet. As we strive for a more sustainable future, embracing LCA's principles and integrating them into our decision-making processes will be paramount. From product design to policy making, LCA provides a roadmap for creating a world where economic development and environmental stewardship go hand in hand.